Hello, you're back for lesson 4.3. So we are going to look at systems of equations, but they're all basically the story problems in the lesson. And so I would like to just kind of jump right in because that's the best way you're going to learn. Let's look at question number 1. So it says one number is 3 more than twice another. The sum of the numbers is 18. Find the two numbers. So we need to first designate how are we going to differentiate the first number and the second number. And then we have to make sure that they add to make 18. So let's try to do that. So I'm going to say X will be number 1 and Y will be number 2. And it says that number 1 is, so that's an equal sign, 3 more than twice the other number. So X, which is one number, is equal to 3 more than, so I'm adding 3 to twice the other number. So that means when I add X plus Y and they equal 18, it says the sum of the numbers is 18. X can really be described by 3 plus 2Y, that's X, plus Y equals 18. So now I have, the key is to get them all into one variable. So now I have 3 plus 3y equals 18. And then when I subtract 3, I get 3y equals 15, and divide by 3, I get y equals 5. Then I know that x equals 3 plus 2y, which is 3 plus 2 times 5. So it says 13. And then we're going to check that. Do 13 plus 5 equals 18. So yes. So my two numbers are 13 and 5. Let's look at number 9. Let's read through number 9 about Mr. Jones. So number 9 says, Mr. Jones has $20,000 to invest. He invests part at 6% and the rest at 7%. If he earns $1,280 in interest after 1 year, how much should he invest at each rate? So a lot of these problems have amounts and values. One equation is going to be an amount equation and one is going to be a value equation. So let's just kind of write that down. So we're going to have an amount equation. And that says for number 9 that he has some amount X plus some amount Y that he invested, and that equals the $20,000 that he invested. And then the value equation in this case is the interest that he earned, right? And interest is earned by taking 6%, 0.06 times the amount he invested for X plus the 7%, so 0.07 times the amount he invested for Y. And when you get the interest at X and the interest at Y and you add it, we know that it makes $1,280. Now we have a system of equations, X and Y, and we can solve from there. Now, we could either use the elimination method and multiply one row to eliminate X or Y, but I'm just going to say, let X equal 20,000 minus Y. I'm going to just solve for X here. And so, and then I'm going to put that into row 2. Okay, so that's my row 2. This is my row 1. So I'm going to put that into row 2. So for X 0.06, I'm going to put 20,000 minus Y, and then plus 0.07Y equals 1280. So I have to distribute this 0.06 here. So 20,000 times 0.06. So we get 1200 minus 0.06Y plus 0.07Y equals 1280. So when you add those, you get 1200 plus 0.01Y equals 1280. Then we're going to subtract, I'm trying to solve for Y, so we're going to subtract 1200 from both sides and we get 80. And so 80 divided by 0.01 divided by 0.01. So Y equals $8,000. So I invested $8,000 at 7%. And so that means X is $20,000 minus $8,000. So X must be $12,000. So I had 8,000, and I'm just going to write this at, and that was at, that's the Y. So that was at the 7%. 7%. And then I had the 12,000 at the 6% rate. These can be a little tricky. Let's look at number 13. It says a man invests $2,200 in 3 accounts here at the bottom that pay 6%, 8%, and 9% in annual interest respectively. He has 3 times as much invested at 9% as he does at 6%. If his total interest for the year is $178, how much is invested at each rate? Okay, so let's write what we know. So it's, I'm going to call it X plus Y plus Z equals $2,200. And so this is the 6, this is the 8, and that is the 9%. So it says he has 3 times as much invested at 9% as he does at 6. So that means Z is 3 times X. So I have my value equation is 0.06x plus 0.08y plus 0.09z equals $178. Okay. And so we can rewrite this first one up here, x plus y. Instead of z, we can put 3x equals 2,200. So that's really 4x plus y equals 2,200. Okay. And then we could solve for y. So we could say y equals 2,200 minus 4x into row 2. So this is row 1 and row 2. So row 2. So row 2, I've got 0.06x plus, and then in case of y, I've got 0.08. And so instead of y, we're going to put 2200 minus 4x plus 0.09. And then instead of z, I'm going to put 3x. So now they're all in terms of x. So now we can use our distributive property, order of operations, and solve for x. So let's do that. 0.06x plus distributing this, that is going to be, figure that out, 0.08 times 2200 is 176. So plus 176 minus 0.08 times 4 is 0.32. So minus 0.32x plus 0.09 times 3 right here is 0.27x equals 178. So I'm going to combine all my x terms. So we have 0.06x minus 0.32x plus 0.27x, and then plus 176 equals 178. So let's combine these. We have 0.06 minus 0.32 plus 0.27. We get 0.01. So we have 0.01x plus 176 equals 178. Subtracting 176, we get 0.01x equals 2. And dividing by 0.01, we get x equals 2 divided by 0.01 is 200. And now we can work backwards. We know z equals 3x, so 3 times 200 equals 600. And so 200 and 600 is 800, and they have to add up to make 2200. So x plus y plus z equals 2200. We know that from up here. So move that down here. So we've got 200 plus y plus 600 equals 2200. So if I subtract 800, I get 1400 must be y. So the 6% interest must have been $200, and the 8% interest must have been 1400, and the 9% must have been 600. And then we can figure out the interest for each, just to double check. So 0.06 times the 200 would have been $12 in interest. 0.08 times 1400 would have been $112 in interest, and 0.09 times 600 would be 54. And if we add them, we get 178, which is just what they said. So that is correct. We did it. Okay. How about we look at another one? How about number 17? So 17 says, these are some mixtures, and if you have to take a chemistry class. So it says a mixture of 16% disinfectant solution is to be made from 20% and 14% disinfectant solutions. How much of each solution should be used if 15 gallons of the 16% solution are needed? So we need a total of 15 gallons, and we need a little bit stronger on the one solution than the other. So let's write down, again, we're going to have a total gallon. So we know that we need X plus Y has to equal 15 gallons. Let's just write gallons. And let's say X is the stronger 20% solution, and let's let Y be the weaker 14% solution. And so we want to mix it so it's at 16%. So it's a little bit closer to the 14% than the 20. So we're probably going to need a little bit more of that 14% solution to like make it a little bit weaker, but we're not sure. So we know that X is the 20% solution and Y is the 14% solution. And so we need this to be 16% of the 15 gallons. Okay, so again, I'm going to simply just say, I'm going to take row 1 and I'm going to say X equals 15 minus Y. It's just easier for me. So I'm going to replace into row 2. So 0.2x, but x is 15 minus y, plus 0.14y equals, and then I'm going to go ahead and multiply that. 16% times 15 is 2.4. Okay, so we're going to distribute here. So 0.2 times 15 is 3. So 3 minus 0.20y plus 0.14y equals 2.4. And we're going to add those together. So minus 0.2 plus 0.14 is a minus 0.06y, and we have 3 minus 0.06y equals 2.4. So if we subtract 3 from both sides, we get a minus 0.6. And if we divide by negative 0.06, negative 0.06, we get y equals 10. So we must need 10 gallons of the y solution, which means if we need 10 gallons of the y solution, we need x plus 10 to equal to 15 gallons. So x must be 5. So we need 5 gallons of the 20% solution and 10 gallons of the 14. It's kind of like if you've ever made like a frozen juice concentration and you had to add water to it to dilute it, or if you're making some kind of a mixed drink, or if you're mixing chemicals for a pool or a hot tub, you're having to do some of that as well. Okay, how about we look at number 21 on page 357. So 21 says, these are rate problems. So it says it takes a boat 2 hours to travel 24 miles downstream and 3 hours to travel 18 miles upstream. What is the speed of the boat in still water? What is the speed of the current of the river? Okay, because when you're going upstream, it's harder to paddle. When you're going downstream, you're going with the current. Okay, so it says it took them 2 hours to travel 24 miles downstream, but it took them longer to travel less miles upstream because you're going against the current, the water. Okay, so let's go back to, there's a really good one in the book here that an example that goes through this. So it says it takes 2 hours for a boat to travel 28 miles downstream. The same boat can travel 18 miles upstream against the current in 3 hours. What is the speed of the boat in still water, and what is the speed of the current of the river? So they kind of read through in the list. And then their step 2, they said, let's make X be the speed of the boat in still water and Y be the speed of the current that's going against it or for it. So when you're going upstream, you have to subtract away the current because it's taken away from the energy of the boat. When you're going with the rate of the boat downstream, you're going to add the current because it gives you more speed. Okay, so then your equations that you're using are going to be your distance is 18 miles and your rate is X minus Y and your time is 3 hours. And then downstream, you've got your distance is 28, your rate is X plus Y, and your time is 2 hours. Now, here is a formula that we talked about in an earlier lesson in chapter 2. Distance equals rate times time. Okay, so we're going to use this equation of distance right here in both situations equals rate times time, rate times time. And so they put those in here. Your rate was X minus Y for down upstream and X plus Y for downstream. And then we have 2 equations when they distributed, and then they solved them. So let's do that with ours on number 21. So we have an upstream is going to be our distance that we were going upstream. So let's just write it. Distance equals rate. And the rate is going to be X minus Y because we're going upstream times time. And it says it was 3 hours to go upstream. And going downstream, we traveled 24 miles. And it was X plus Y. And then it only took us 2 hours. So we have row 1 is 18 equals, I'm going to distribute through, it's 3X minus 3Y. And then row 2 is 24 equals 2X plus 2Y. Actually, I could have just divided both sides by 3 and gotten 6 equals X minus Y. That's what I should have done. And then on that row 2, divided both sides by 2 and gotten 12 equals X plus Y. So let's use those. Because this is something times 3. So if we divide both sides by 3, then we just have the X minus Y left over. So then the cool thing is we can just add our equations because Y's cancel. So we have 18 equals 2X because our Y's cancel. So X equals 9. And remember, X is the speed of the boat in still water. So still water speed. And we said that that is 9 miles per hour. And so that means we can just go in and say 6 equals 9 minus Y. And we're trying to solve for Y. And so if we subtract 9, we get a negative 3 equals a negative Y. And dividing by a negative 1, we get Y equals 3. So the current is 3 miles per hour. Okay. The last problem I would like to do is number 25. And it is all about coins and their value. So it says Bob has 20 coins, totaling $1.40. If he has only dimes and nickels, how many of each coin does he have? So I like the coin ones because I can just label them. Dimes are D's and nickels are N's. Okay, so we're going to have the number of coins and then they're going to have their value. So we have some number of dimes plus the number of nickels. And remember, we did something fun in my Math 104 class. We did something fun with this on the first day of class with money. Dimes plus nickels, and we said there's 20 of them, 20 coins. And we know that dimes have a value of 10 cents. So this is our value equation. And the nickels have a 5-cent value, and their total is $1.40. So this is our count equation and then our value equation. And so I'm going to say let D equal 20 minus N. And that's my row 1 and my row 2. And then I'm going to put that into row 2. So 0.10, instead of D, I'm putting 20 minus N plus 0.05 N equals $1.40. And we're going to distribute here. So 0.10 times 20 is 2 minus 0.10 times N plus 0.05 N equals 1.40. Our like terms, a negative 0.10 plus 0.05, we get a negative 0.05 N equals 1.4. And if we subtract 2 from both sides, we get a negative 0.6. So if we divide by a negative 0.05, we find out that we must have had 12 nickels. So dimes plus 12 nickels equals 20 coins. We must have 8 dimes. And we can just check that by saying 8 dimes times 10 cents is plus 12 nickels. Does that equal $1.40? So 80 cents plus 60 cents does equal $1.40. So, we figured it out. Woo, we got through that one. Great job. So that concludes lesson 4.3. And that is going to be the last one that we're going to do for this chapter. Lesson 4.4 is about systems of linear inequalities. And it just builds off of what we learned about inequalities earlier in, in the semester. And so we're not going to look at that this semester. But I will kind of just share with you a little bit about how you can use Desmos, which we did a lot in our inequalities anyway. So this example here on page 362 in 4.5, we have the equation x plus y less than 4. So if we graph x plus y equal to 4, that would be our red line right here. Okay. And then the line negative x plus y less than or equal to 3 is an including, so that's why it's a solid blue line. And we want to know where they intersect and where they're both true. And so where they're both true is in this shaded region right here. And so that means this would be our solution. And then you can see the second example, or example 1, they call it. They've got this, we've got a slope of 1/2 plus 3. Where is y less than that? So they shaded over here to the left with a red. And then the other one is a slope of 1/2, but x, the y-intercept is -2. And where is it greater than that? So they shaded above the blue line. And we want to know where they're both true. So if we graph them together on the top of page 363, we can see that there's a small slice where it makes both inequalities true. So that's essentially lesson 4.4 builds on the inequality knowledge that we learned earlier in chapters 2 and 3. So catch me back for the next lesson.